All right, welcome to the third talk of this afternoon session, iRODS user group meeting on Wednesday. Mike Conway and Deep Patel from the National Institute of Environmental Health Sciences, or the NIEHS, are going to talk about all they've been working on for data management at NIEHS. Mike and Deep, say hello.
Hello, glad to be here. I'm Mike Conway from the Office of Data Science at NIEHS, and my colleague Deep Patel is here. I'll do the presentation, but I wanted to make sure that Deep was able to take a lap because he's done a lot of work on this and other iRODS issues, so he'll come back for the Q&A.
It has been great working with iRODS. It's been 2 years something, but it has been great working with Mike and under him he has been awesome with all iRODS, and it's been great. I will just give it to Mike, right?
Okay, thanks. And so what we're going to talk about is, there's a lot we could talk about, but I tried to winnow it down to sort of two areas that are sort of actually our concern and I think are common. And some of these things I've hinted at before, but I'm trying to tie together some of the different activities that are going on in the consortium and hopefully trying to engineer things so that we can, sort of take a lot of work from some different people and put it into NIEHS. So, the whole notion here is, well, what's keeping us awake at night and compared to you all, and here's two of the things that I'd like to mention. First of all, I started at NIEHS after I had been at RINCI while we were working on the NIH Data Commons as a question. So there have been a lot of efforts at building a commons that ties together all the different parts of NIH. So we're broken up into what we call ICs, so things like NIAID, where Dr. Fauci is, or NCI, the National Cancer Institute. So among these institutions, there is more and more this notion of data sharing. You're seeing a rapid stand-up of sort of shared resources, workspaces to respond to COVID, and that's going on within NIH as well as across IC things with like research data lines and so forth. And so a lot of these COVID efforts, for example, and things like the Cancer Moonshot, they're all based on this notion of sort of common platforms. So a group of platforms that conform to certain standards, including authentication, authorization, and they all have similar qualities. So here I'm showing Gen3, which is something that's coming out of NCI. The sort of middle one there is Terra. And so you're seeing lots of applications that are built on this Terra platform, and then Discovery Environment there, hiding behind the corner. And, they all have, sort of very common notions of data discovery, the ability to plug in data models, to do search, and to link with data in other systems. A lot of these are biased now towards sitting on top of cloud data. We are working on cloud pilots right now and trying to absorb that. So as an iRODS person, iRODS has a lot to offer, especially we feel in this area of spanning both the local resources, our DDN and our NetApp and various sort of storage we have within our organization, and to combine that with the cloud data that's in Amazon, where we have lots of stuff, and also in Google Cloud, particularly. This is the STRIDES effort at NIH. So we want to try to work to make sure that iRODS can be a source of data and metadata and can be a target of computation in all of these platforms. And so we're really trying to sift through this now and see what do we need to do to make iRODS middleware relevant and accessible from some of these platforms. And looking for a pathway to play together nicely. So another thing that we're trying to do is, while we're reaching out to NIH and some of these different efforts like Gen3, we're also trying to reach out to, standards bodies. So there's Pistoia, there is GA4GH, there is RDA. I've been putting a lot of my focus on GA4GH specifically because a lot of the things that NIH is doing in their Commons umbrella have analogous representations in driver projects in GA4GH. So for example, this notion of authorization and authentication that we're all talking about as well as data sharing agreements is represented both in NIH internal sort of efforts, and then that is mapped directly into GA4GH with this DURI researcher identity data passports notion. And so if you think about data sources that can sort of mediate different storage technologies, what does that sound like? That's why we're all here. And then also this notion of federating between different sites who are sharing data and putting them under a common authorization model that goes beyond just what group access do I have, but also based on sort of interpreting data sharing agreements between sites and auditing and enforcing them. What does that sound like? Okay, so I think there's a real natural fit here, and there's an awful lot of work that goes on here. So I did want to point out, I'm not going to really present this today, but we did show at the last GA4GH plenary, we did show a DRS, Data Repository Service interface to iRODS. So DRS is part of the cloud workstream, and that's this notion that you have CWL or WDL workflow languages, which are able to run tasks on different platforms. So the workflow can send this task to this cloud, this task can run in this private cloud, and then they can access data in an abstract fashion. And so that DRS API we've implemented for iRODS already, and we want to see that work with the 7 bridges and the Gen 3s and so forth to be able to put iRODS data underneath that stack. So as you get into this idea of compute to data in the health area, this cloud workstream and the DIRS, TERS, and WES stack should be on our radar screens. Okay, so there's a link at the bottom. That is the GitHub repo where this compliant DRS repository is. So I'm going to put that aside. I just wanted to give a shout out to that if there are people who are working with GA4GH. What I wanted to talk about here was handling metadata and curation and getting beyond AVUs. This is the whole notion you see with Yoda and the metadata templates working group. And then the mechanics of the ingest of data and metadata. Particularly here, we want to talk about how you can take metadata and serialize it into AVUs and get it back out and manage it. We're also interested now in bolting SCOS and vocabularies, especially through Synaptic or Graphite, into our commons. So through the metadata working group, I'm talking a lot about how do you have control vocabularies and SCOS terms as part of that. Indexing is something that the consortium is working on, and I was really hoping we could do some Hackfest, but it sounds like the time is not quite ripe. But what we'd like to do is see how we could tap into the indexing capability that Jason and Terrell and those guys are cooking up. Okay, so now I have an index. How can I search it without polluting the community code base? Specifically, how can we make search that bridges different search technologies that are being indexed and put that into things like Metalinks or REST API or even from the command line or GenQuery? Okay, and how can I create searches that are usable by relevant communities? And so how can I do micro-targeted search? And that's what we're going to show. So in the metadata template working group, and I really encourage people to check that out, we're looking at how to structure metadata. And so, looking at things like Cedar for defining templates. The shot there below there, this K9, that's Gen 3. And so a lot of these cloud platforms or these commons platforms have this idea of you can import and define new data models and put them into the interfaces, and then you can create, faceted search or different kinds of search on top of that interface by plugging in these data models. So I think that this direction is really fruitful, and you can see we've got some catching up to do, honestly. We're working on, we have our data commons, and now we also have something we're calling Metacat, which we're just starting with. This is Synaptic with Graphite, and the notion is to start having cross NIEHS. We're across the water from EPA, so we're also talking with folks like EPA or other ICs within NIH on what vocabularies do we use and start having a common data model across our organization. So we're trying to pull these things together. So in my mind, in an ideal world, the metadata templates working group can create metadata templates that can be picked up by this indexing capability. This is a thing that hopefully Jason can do a lightning talk on. And then the idea of how can we have pluggable search for different personas and then put that into interfaces and virtual collections. Okay, so I'm going to pop over to the demo side here, and I'll just show you a couple of things. So the way we're working this is we have created a Swagger API definition, which is super simple. So what you do is you create in our case, we're creating little Python Flask applications that conform to this API, and it really has like 3 primary endpoints right now. First, each little endpoint can advertise what indexes it supports. So think of a schema, and I'll show you, like we have schema for things like sample search, project search, and we're also working now on a generic file and metadata properties search for iRODS. So you have a collection of endpoints that advertise that they are of a certain, they support certain index schema. Then each schema can advertise what attributes it supports. So for example, I have an attribute, and it has a certain data type, and it has user info about what those parameters mean. Okay, then you have a query endpoint. So you post a search query, which in the first case is going to be a free text little language that essentially maps to what you would use in like a Google Advanced Search or PubChem or something like that. So you simply post that search with a couple of flags, and then you can plug that, then that search plugin will take the little language text query and then just translate it. In our case, we're really resting on Elasticsearch DSL, but this also works for Sparkle and SQL. To go back to the slide for a second, what I wanted to show was this. So we're showing this in Metalinks, and we've added some new configuration in Metalinks. Specifically, you give it a list of these endpoints as just their HTTP URI, and then you enable pluggable search. That's really all that's required. And so in this example, this is a dev server. When you fire this up, when Metalinks starts, it will go out and it will query those configured endpoints. And you can see here, it's now pulled in all the schema that have been advertised from the various endpoints. And so here's like a real world example. I can't show any data, but I can show you. We have a project search now where you can search on PI name and scientific hypothesis, organism of interest. We also have one now for epigenomic samples and runs. So things like who prepared the library. So I want to show everybody who is doing RNA-seq that was prepared by this this technician using this reagent, etc. And you can then build these queries as text and pass them through that post API, and they're translated in this case into Elasticsearch DSL. In Metalinks at the moment, this is something that people have not, like users have not liked at all, which is this search that is a metadata search that is split between metadata and file properties, but you can't combine the two. And ands and ors and so forth. So we're looking at ripping this thing out and replacing it with global search. So the global search, again here, what you do is you select a schema. In this case, I'm doing metadata search, and I just had like a canned one I was using, which was, I think it was like, I'm just gonna search on an AView attribute. I think it's business suitable. Yeah, and so what I wanted to show here is when you query, you can return it as your sort of Google-like listing, you have the option to format that. So when we're doing a project search, for example, there's sort of a scheme where you can have headers and description documents, and you can also have sublinks. So we can search on a gene, find projects that are looking at that gene, click on the project, and inside the search, then you can see a listing of the runs, the runs that are associated with the project. And we're also now adding this notion of a grid, and we're still kind of pushing this in the right direction that we want this to, the notion is you can advertise as supporting an ILS format in these query things. So in this case, what we're doing is we're trying to return a file listing based on that query. And I don't know if you guys remember back in the cloud browser days with Cesar, that notion that you can take a query and save it and then represent that as a collection. That's what we're trying to do here with the grid search. So we're trying to massage this and actually build like a new collection listing within Metalinks under the search grid. And then what we want to do is rip out the collections that is currently in Metalinks and replace that with this new search. I just wanted to make a technical note with Metalinks. It's based on Timely, so this is a template rendering application. And as we go through this and add new functionality, what we're trying to do is replace it with single page apps. So this is using Vue.js, and so sort of within the structure, we can start ripping out pieces and replacing it with single page apps for each of these main categories. So here you're actually looking at like a proper Vue.js application that's calling RESTful endpoints. So the notion here then is becomes rather easy to just create new new searches based on different search personas, and it's easily pluggable and extensible. And so yeah, so that kind of gives a hint at some of the work we're doing. We are running Metalinks in production. It's you know, we love it, we hate it, but it is working for us. And so this is kind of a notion to the pathway that we think we can get to, where we can, again, start replacing things piecemeal with single page applications and keep it running. And again, what we were looking for is sort of pushing into that indexing capability as it comes out of iRODS, and make a what we would really like to see would be a standard schema and an indexer that will index file and metadata. And then we can also then just produce a conformant plugin that can replace this general task of AVU and file query. You know, show me all files of a certain size that are tagged with this attribute, you know, created on a certain date, those kinds of queries. So that's really hard to do with jQuery. I also did want to mention that, you know, we're inspired a lot by PubChem. So we do intend on starting with these sort of textual queries and then extending it to the ability to have, you know, sort of builder type search queries where, you know, you can add statements in this sort of manner, but it can work using the same mechanisms. So I just wanted to mention that. There's a lot of other stuff going on with libraries. We have things cooking with Python, with the jargon libraries. We're bringing back iDrop. We're going to continue to work on DERS. I'm also working on a little FTP implementation. And with that, I don't know if Dawn is yelling at me yet, but I think we can sort of stop there, and maybe if there are any questions. But the main thing for me is can we keep pushing in the metadata templates working group and link that with this indexing effort? And if you do that, then you can just plug in these little search containers easily into this interface or others, and you're off to the races. How does that sound? Terrell, Dawn, you want to jump back in?
Well, that was very quick. I don't know if we've ever had a Mike Conway talk end early. This is...
I'm working on it.
Yeah, you know, you
I'm
caused
working
me a
on it.
surprise though. I don't know that we've got any questions right now. Can you talk more about what it would take to get iDrop ready for people?
Yeah, I can give if there's time, I can give a quick preview on that. I'm actually running it here in the background.
Yeah, you do have plenty of time right now.
Okay. So where are you? There we are. So there's actually nothing to do to make this work. It's a question about how to make it better. This is a really fast client. It does have that, and one of the beauties of this thing, you know, you can see here it's got the sort of standard motif like an FTP window where you have the local compute system here, local storage here, and then on the right hand side here is the iRODS grid, and it has the standard sort of things. You can target different storage resources. You can create directories and so forth. There's an info panel that has a few things. It's got, your sort of general data. It's got AVU and attribute setting built in. That part needs some expansion. But I think the most interesting thing, because this was actually built for doing sort of archival transfers. And the notion is that you can stack 50 transfers in this client and then just close it and it runs in the background. And what this thing does is it will monitor all those transfers as they occur. It will log file by file what happened. If there is an error that occurred in a transfer, it will again give you a file. In this case, there was an error occurred in this transfer. I can look at each file, and then I can also see what error occurred. So this thing does have this notion of soft failure. So you can turn it and say, if the transfer has one file that is an error, just go ahead and finish it. But if you get like over 5 errors, it will cancel. But then built in here too is also the notion that you can, go in and resubmit or restart in place. So it sort of creates a manifest of what you've of what your transfer activity. And again, the notion is it has a queue, so you can come in and I can just start dropping 50 transfers in here and just let the thing run. It does have background sync. You can do a diff on demand between a local and a remote iRODS server. It's got a lot of tuning. I think what it needs is some refacing because it's starting to look sort of 1990s at this point. But it does parallel transfer. It also has actually a rule engine built into it, so you can write little microservices and script them. I can show that maybe in the lightning talk, but there's a little language. You use Groovy scripting, and you can also write microservices, and the microservices can both interact with iRODS and the metadata and the local data. They can also interact with the queue, so it does support a scenario like this. I can set up a rule that says if I'm transferring over 100 small files, instead of transferring those files, it will instead locally create a zip or a tar, and then take that transfer off the queue and then just enqueue a transfer of the zipped file. So you can do like queue manipulations using that little language. You can do things like gather extra metadata on the client system and add those as AVUs. You can do additional checks, encryption. So those are just some of the possibilities, or those some of the things that this supports. It's cross-platform, and it actually is super stable. And there's so here's some of the tools you can see. So you do have here's where you can perform the diffs, or you can set up automatic synchronization between directories. It also has let's see what else I have. It has this facility. You enter a passphrase when you log in, so it can remember multiple grid accounts. So you can sort of switch between grid accounts as you go. Those are just a couple of things about it. And the only reason it's not out there is just because I haven't had time, but we actually use this sort of daily right now. The other thing that's really interesting is it's super configurable. So you can do all your parallel transfer tuning, and you can also do, tuning of all the it has knobs for some of the buffering too. So you can also play with buffer sizes and so forth for optimization. So that's like the 50-cent tour of that. So that is one thing that I do want to put back out there for folks to use, and we can reface it.
Where would one get it if one would want to download it?
I will post something to iRODS chat. It's actually out there on GitHub. I think it's out there still under Dice UNC. Okay. But
I know you and I had talked about transferring a few different repos. I think this might have been one of them.
That's right. And in the background too, I am working on updating the Java client. There's and I'm also doing some work on Python. So both the current as well as maybe some new ones. I know for Java, I want to look at doing a clean room at some point. I've been playing with that and doing it using non-blocking I/O and doing a java.nio implementation that is native iRODS.
Right. I know that Corey was interested in that as well, now that we've got the clean things.
Right. And then kind of the same for Python. There's some things I want to put into the Python to sort of cover more elaborate cases. There's all kinds of edge cases to cover. Yeah. So we can do more on that in the lightning talk, but you know, activity on the metadata is probably one of the most important things to us right now.
Right.
And with that.
Okay, I've got a couple more questions here. One from Brett at Sanger. He says, we're looking into using Metalinks and indexing together for better search. He put a little TM around that. Am I right in understanding that the combination doesn't currently have multi-attribute search?
It does have multi-attribute search.
Find all the objects which have both foo and bar set as the attribute.
Yes. Now, to be fair, we are working on the Elasticsearch schema. So the schema is we have like a file object schema, and then it uses the AVU attributes as nested elements in the Elasticsearch schema.
Right.
And so the notion is these little searches are targeted towards a persona. So we bake in a lot of assumptions about how they're searching. This part is fuzzy, this part is an exact search, and you know, we can tweak the distances and so forth. We tolerate. There's type information. So the little trick is how you turn the query into the DSL. And right now, Deep and I are playing with how to best tune the DSL so that it can most accurately search ands and ors of multiple attributes and units. And if Deep has popped on, maybe he can comment on that. But we do have experience with tuning these DSL to do exactly that.
Yeah, it's just that we are trying to keep it simple for the start with the generic search, and then once we have a query builder kind of stuff, we can give more power to the users to have like ORs, and which can have a kind of a tuple search, like attribute is foo and value is bar, and then do an OR with another pair of attribute value.
Right, but these aren't arrays
where it's a bit difficult.
Yeah, the AVUs are nested in the mapping of Elasticsearch, so that the attributes are treated together with the values and the units and so forth. So it doesn't do funny things that way. So the answer to that is yes. And then it's really quick to put these up for different personas. So a bioinformatician versus somebody in mass spectrometry. We just keep throwing new little searches in there and target at those personas.
Right. Very good. We have one more question. See, considering that you're using human genetic data, are you using encryption at rest for the data that's in iRODS? And if so, how does that work and what are you doing?
We are at this moment not using human genetic data. Our focus right now is on our primary use is mouse data, zebrafish, so forth. Human data is on the roadmap. But this is right now in the policy stage. In other words, we have data retention and data governance committees that are working. So you need the English policy before you get the computer policy. But yes, we are looking at that, and I think we definitely want to look at differential treatment and putting them on totally separate storage resources that can have encryption at rest and those sorts of things. So, but it's all based on good metadata, honestly.
That's right.
So that it's metadata all day long. You can't have data governance unless you have this data marked up correctly.
That's right.
Yeah.
Raja did ask, he says, does iDrop have share capability? Does it allow you to, does it know about other users?
It does not, except in the sense if you can do permission setting.
Mm-hmm.
But this gets into that sort of global definition of what is a share.
Right.
This is where interfaces are really hard, because it's really hard to come up with these sort of metaphors and practices that actually sort of need to be embedded in the server. And now I'm starting to sound like me at one of these things. But like, what is a tag? What is a share? And how do we treat that? You know, it's like Cyverse treats it one way. We at DFC were treating it another way. Or when we were building Cloud Browser, and sort of getting a consensus on that is the hard part.
Yeah, we definitely hear from new people, and they have all these questions, and every answer they give is different than everybody else we've ever talked to. And so it's really hard to, and they don't understand why we don't have a UI just for them.
That's right.
It's
well,
complicated.
Patel Raja too. The other cool thing is you can generate a manifest of the data that you are going to send to the target server, and then you can then say, is the data that people were saying they were going to put on iRODS, has it shown up, or what's inbound?
Right.
So yeah, so that sort of thing.
And Ton at Utrecht says he's very excited and would love to have metadata template support in iDrop. So I'm not sure you said that, but he's very excited about it.
Well, if we can get the templates in Cedar,
yes,
or you know, if the template, if we can farm out the building of the template to a thing, then I think the data entry would be super exciting. And then the other thing too is you can use those templates to create search forms. That's like the other piece of this that we were looking for.
Very good.
All righty, is that enough stuff?
Yeah, enough. Deep, do you have anything to share? Anybody have any questions aloud or written otherwise?
No, I think Mike did everything.
Deep did a lot of this work though, so I want to make sure Deep can take a victory lap.
Very good. Well, thank you both, and we are on time. Thank you.
Thank you.